Welcome back to the channel. In this video, I'm going to show you how we can use GitHub Copilot with the Power BI Modeling MCP extension inside VS Code to build a fully functional Power BI semantic model complete with business measures based on the sample Databricks BakeHouseSales dataset. If you haven't yet watched my previous video on how to set up the modeling MCP and generate documentation, definitely check that out first. It's the foundation for what we'll be doing today. In this session, we'll connect to our BakehouseSales data and use Copilot to turn raw transactional tables into a properly structured data model. I'll also show you the prompt structures that help Copilot generate table relationships, hierarchies, and DAX measures that align with your business logic. Now, before we dive in, it's important to understand the tool's scope and limitations. The Power BI Modeling MCP is designed for semantic modeling, tables, relationships, and measures, but it does not support creating or updating dashboards or visuals directly in Power BI. Technically, it can generate or modify SVG files, but that's not particularly useful for day-to-day BI report development. So think of it as your modeling assistant, not your full report builder. The real value here is how it supports both development and business teams. For developers, Power BI MCP accelerates the technical setup, reducing repetitive work and ensuring consistency across projects. For business teams, it helps bridge the gap between transactional data and business insight, allowing faster iteration and better documentation. Now, of course, this doesn't replace expert human data modeling skills. A solid understanding of data architecture, star schemas, and business context is still essential. What Power BI MCP provides is a way to enhance those skills, helping you model faster, validate logic quickly, and focus your time on refinement and interpretation instead of setup. If you're curious about how AI can elevate Power BI modeling workflows and strengthen collaboration between technical and business users, you're in the right place. Don't forget to like, subscribe, and hit the bell icon so you don't miss upcoming deep dives. All right. Let's jump into the demo and see it in action. I'll start by importing the transactional Bakehouse sales tables, which include customers, suppliers, transactions, franchises, and reviews. Once everything is loaded into Power BI, I can switch to the model view to explore these tables, relationships, and overall structure. Alongside Power BI, I'll have VS Code and my agent editor open. I like to keep them side by side because it makes it easier to see changes in real time, run prompts, and iterate quickly without switching back and forth between applications. It keeps the workflow smooth and efficient. Next, I'll prompt Copilot to connect to the open Power BI Desktop file called BakehouseSales and describe the data it finds. Now, this is a critical first step to confirm your agent can successfully connect to and understand the open Power BI data model. Once connected, Copilot will return a confirmation message along with a brief summary of the existing data, which gives us a quick overview before diving into the modeling and measure creation process. I want to take things a step further and actually reshape this into a proper analytics model. At this point, I'm going to give the agent a detailed, structured prompt that tells it exactly how to turn this flat, transactional model into a well-designed star schema and then layer on business logic and documentation. Think of this as handing Copilot a playbook for how an experienced data modeler would refactor and organize the dataset, separating facts and dimensions, building relationships, adding validation checks and business measures, and fully documenting the model so both development teams and business users can understand and trust it. Let's break down each instruction. First, I tell it to analyze the Bakehouse file and classify tables as facts or dimensions, renaming them with fact underscore and dimension underscore so the model's roles are obvious. Then I have it build proper one-to-many relationships to form a real star schema with good referential integrity. Next, it cleans up the model, hiding noise, masking sensitive card data, and adding friendly display names so the fields make sense to business users. I ask it to apply dimensional best practices, logical column names, no redundant fields, and a single source of truth for each attribute. It also adds a DimDate table if one's missing and connects it to all the date fields so we can do robust time intelligence. I also have it create validation measures like row counts and integrity checks to make sure the transformation didn't break anything. From there, it generates real business measures, things like year-to-date sales and month-over-month growth, plus top product style metrics. The model then gets organized for readability with consistent naming and a logical structure, so it's easy to navigate. I tell it to fix any errors it hits along the way instead of stopping halfway through. It documents the whole model with full sentence business descriptions for every table, column, and measure. Finally, it produces a before-after summary of the tables and a Mermaid diagram of the new model so we can visually confirm the end state. The final result is a nicely documented transformation of the model. You get a before and after summary table that shows how each table started, what role or issues it had, what it became, and the key changes applied, along with a Mermaid diagram of the new star schema that clearly lays out the relationships and confirms the new semantic model is in place. From here, we can jump over to the Power BI model view to see what this actually looks like in the semantic layer. You'll see the fact tables sitting in the middle with the dimension tables around them, all wired up with clean one-to-many relationships that reflect the star schema. This is where it really starts to feel tangible. Instead of a tangle of transactional tables, you now have a structured, business-ready model that's much easier for report authors and analysts to work with. Filters flow in a predictable way, relationships are clear, and measures are defined on top of a model that actually matches how the business thinks about sales, customers, products, and time. And they're organized in folders, and the field descriptions are documented descriptions. But just to be clear, this didn't come from a single perfect prompt and instant results. It took several follow-up prompts, clarifications, and change requests to get the structure, naming, and business logic to the point where I was happy with it. And that's exactly why strong data modeling skills are essential. You need to understand facts versus dimensions, grain, star schema, and your business process so you can spot when something is off, fix relationships, refine DAX, and decide whether the output is truly usable for the organization. The assistant can generate structure and measures, but it doesn't actually understand your business context or data quality constraints. When you bring that expertise and combine it with this workflow, you get a real multiplier. Development teams can build models faster, reuse consistent patterns across projects, and ship with validation and documentation. Business teams benefit from a clearer semantic layer, better defined metrics, and a shorter path from messy source systems to trustworthy reporting and analytics. So this isn't about replacing data modelers, it's about amplifying them. The modeling MCP helps with the heavy lifting, restructuring tables, writing relationships, creating measures, and documenting fields, while you stay firmly in control of the design and the business meaning. If this walkthrough was helpful, make sure to like and subscribe so you don't miss future content. Thanks for watching.